This is video part 2 of lab 7 for course EE352. In first part we have seen the concept of direct memory access DMA, its motivation by looking at the real time example, frequency spectrum, conceptual diagram of DMA on TMS320c5515 DSP kit, DMA basic architecture, and how the input and output DMA buffer are divided into two parts, ping and pong. Now we will see how the DMA implementation on TMS320c5515 kit. So if you open your skeleton code of lab 7 and import the project DMA checkup, you will, in the left you can see that these many files are added there, and if you open your main.c, you will get this file. To understand main.c, I have divided this file into different segments. First segment, header file. Second, flag bits. Third, buffer for DMA input output. And fourth will be your main code after it. So if we see this buffer for DMA input output, DMA will take data from codec and store in DMA INPL, DMA INPR, and will take data from DMA OUT-L, DMA OUT-R and set it to codec. But how DMA has to save data in this buffer? So this is mapped in this header file. We will see how and where these are mapped. So if you see line number 14, in comment also it is written that these flag bit determine whether ping or pong buffer is filled. So whichever buffer is filled, programmer has to read that buffer, and other buffer DMA would be filling with the new data. So again the mapping of that, whether how these flag bits are changed, is done in this header files. These flag bits are 0 if data is available in ping, and these flag bits are 1 if data is available in pong. So the definition of these buffer, this mapping of these buffer and variable are done in the header file setup DMA underscore setup.c, and declaration of that is done in DMA underscore setup.h. So these are the two files which we will observe now. So if we open DMA underscore setup.h, you can find the declaration of the variables in the buffer and declaration of the function DMA 0 underscore setup. And if we see the definition of this function which is there in DMA underscore setup.c, you can see the DMA buffer are mapped to DMA controller number 0. So in this kit there are 4 controllers, so we will use only controller number 0. Same thing for flag bits, you can see their mapping in this interrupt void DMA ISR function, which is also defined in DMA underscore setup.c. Pong is set to 0 if ping buffer is available to be read, and it is set to 1 if pong buffer is available to be read. Now if we see the main function, you can see that we have called this DMA 0 underscore setup. That means by calling this function in line number 108, we are mapping all our variables and flag bits to DMA, and also we are enabling DMA 0 controller. After enabling DMA 0 controller, you will find a while loop. A programmer should know in while loop he should write 3 blocks. First block should be data acquisition from ping pong buffer, and second block should be data processing, and third block should be putting data on ping pong buffer from where DMA will read data and put onto the codec. So in this I have shown you only 2 blocks. From line number 4 you can find block number 1 data acquisition, and in line number 25 you can find the second block processing block. Before we go to the flow of this code, some key point to be remembered, that if ping buffer is read and then processed, in next iteration only pong buffer should be read, not the ping one. That is taken care by this flag bit. And if in one iteration ping buffer is processed, so in next iteration same ping should not be processed. This is taken care by this data captured started flag. Starting with the flow of this little code, you can see in line number 4 we are checking which portion of this DMA buffer is available, either ping or pong. So if condition of line number 4 is yes, that means pong buffer is available. So you can see in line number 8 and 9 we are reading second portion of this DMA buffer, that is pong, and storing its value in buffer L and buffer R. Line number 18 and 19 you can see we are storing the first portion of DMA buffer, that is ping, to buffer L and buffer R. And in line number 25 we are, before we start processing we will check whether data has been captured or not using data capture started bit, and if it is yes, we will do the processing by reading data from buffer L or buffer R. There is one mistake in line number 11, that it should be data captured started, not data captured 0. So please make a note of it. So after doing processing, one more thing is missing, that data captured started should be set to 0. After understanding the implementation of DMA, you can build many applications. One of the application DTMF decoding was part of your application assignment. That's all from my side. Thank you.